So, without further ado, we'll start with this a panel. I will talk first, basically because I don't have too many interesting things to say, because the real researchers of the project are over there. So I'm going to give just a general introduction. I'm sorry, the microphone is not really set for dreadlocks. So we are installing the PowerPoint. Oh yeah, yeah. Okay, and we can already go through the first slide. No, sorry. Yeah. So the Voynich manuscript, composed in the early 15th century on calfskin parchment, offers 234 pages of text in an alphabet no one can read, accompanied by drawings of plants that do not exist, constellations without astronomy, and human figures absorbed in rituals that elude comparison. It looks like language. It repeats like language. It has the statistical texture of language. Yet, after cryptographers, medievalists, computer scientists, and even intelligence agencies have all tried and failed, we remain uncertain whether it is a language at all or simply an elaborate illusion of meaning. History is rich with indeciphered, undeciphered scripts. Think of linear A, the Cretan precursor to linear B, still mute despite a century of study. Thinks of the Indus Valley seals, thousands of signs incised on stone, their brevity tantalizing, but their grammar impenetrable. Think of the Rongo Rongo Glees of Easter Island, whose wooden tablets survived fire and conquest, but not interpretation. Each of these scripts resists us, yet in each case we are confident that sense exists, that meaning is there, because human communities with human intentions left these marks. The mystery is epistemological. We do not yet know how to read them, but we know that they were meant to be read. The Voynich is different. It was produced by human hands with quill and ink, but here our uncertainty is ontological. We cannot be sure whether the text is an encrypted message, a lost language, or simply a dazzling mirage of meaning. It is not just undeciphered, it may be undecipherable in essence. This threshold matters for semiotics, and it matters for biosemiotics, because today, with artificial intelligence, we stand before other kinds of Voynich manuscripts, the vocalizations of whales, the dances of bees, the signals of cephalopods. We build systems to parse them, to correlate patterns, to propose translations. Yet the fundamental question remains, can we speak of translation if we cannot be sure that the system we interpret is endowed with meaning in the first place? Now consider another image drawn from, I don't know if there are any Hungarians in the audience. Well, from Ferenc Karinti's 1970 novel E Pepe. This is the Italian translation, but the Hungarian title, but the English title is Metropole. What is the story? A brilliant linguist, Budai, of course, boards a plane en route to a linguistics conference in Rotterdam, no, Helsinki, but wakes somewhere entirely else in a vast, suffocating city. Its language, the language of the city, is unfamiliar, its streets incomprehensible. Despite his mastery of dozens of tongues, from Sumeria runes to modern European idioms, Budai cannot make sense of a single syllable. Yet he interacts. He is swept through the crowds, lodged in an anonymous hotel, carried into routines he does not control. He even falls into a desperate intimacy with the elevator operator, the enigmatic E Pepe. And still, nothing becomes clear. Communication occurs, interaction happens, but sense, meaning, eludes him until he begins to suspect that perhaps what he hears is not language at all. This is the heart of the matter for us in biosemiotics and AI translation. There may be systems, whale song, bee dances, cephalopod displays, etc., that orchestrate interaction without containing meaning in the sense we expect. We must ask, can there be translation where there is interaction but not interpretability? Can a system allow for functional exchange without being semantically grounded for us or perhaps even for them? What then do we mean by an interpretable language as opposed to a merely functional science system? The crucial difference lies in the possibility of failure. A language such as human language allows interaction, sometimes smooth, sometimes broken, but always vulnerable to error. Precisely because misunderstanding can occur, interpretation becomes necessary. Language is not simply a vehicle of functionality, it is a medium of perpetual negotiation where every utterance risks being judged correct or incorrect, adequate or inadequate. For instance, you might be thinking now, what the hell is he saying? When the space for such failure diminishes, interpretability diminishes with it. Certain systems of science, mechanical signals, automatic codes, or instinct-driven exchanges may coordinate interaction flawlessly, but they do so in a way that leaves no room for doubt. They cannot break down in a semiotic sense. If they fail mechanically, not symbolically. To use Peirce's categories, they operate dyadically, stimulus to response, rather than triadically, where the sign opens onto interpretation. Semiotics begins precisely where the possibility of breakdown, of a stumble in communication, is inscribed in the system. This is the paradox that Ferenc Carinthi's Pepe dramatizes. The protagonist finds himself in a city where interaction is incessant, yet semiosis is absent. He can move through crowds, perform routines, even enter intimacy, yet never interpret. The city seems to run on automatism, not on meaning. By contrast, the Voynich manuscript invites projection of meaning, yet in a dangerous way. If it is not a language, it will accommodate any interpretation, saying yes to them all. That is not interpretation, but it's negation, because interpretation requires the possibility of error, of rejection. Thus, the distinction is decisive. Translation is not the rendering of functionality, but the rendering of interpretability. What we translate in language is not its efficiency in securing interaction, but its openness to doubt, its margin of failure, its demand for interpretation. We're often tempted by a kind of optical illusion of language to assume that wherever there is interaction, there must also be language. Yet perhaps we should invert the criterion. Language appears not where interaction flows, but where it can break down. This is another way of formulating what Umberto Eco once suggested and what semiotics has taken up. The sign is whatever can be used to lie. In other words, semiotic status, not the smooth transmission of signals, but the possibility that communication may be diverted, distorted, or denied. A system is linguistic when it admits not only functionality, but also dysfunction, not only transmission, but also miscommunication. This inversion helps us to situate an ancient dream to understand what non-human or more than human, if you want to say so, animals say, or might say. For centuries, humans have projected onto animals, plants, or gods the hope of a perfect transparency of meaning. But behind this projection lies an anthropological truth. We desire this transparency because we lack it among ourselves. Human language is fallible, fragile, forever under negotiation. We long to overcome its uncertainty, and so we imagine that whales, birds, or angels might speak with a clarity denied to us. In medieval theology, angels were said to enjoy absolute communicative transparency. In our technological age, artificial intelligence is recruited to pursue the same utopia. Our project, which my colleagues Nicola Zanjaro and Daria Arkhipova will present in detail, is precisely a meta-reflection on these efforts, on what it means ethically and semiotically to invest so much in deciphering whale songs, bird calls, or cephalopod flashes. Certainly, there are intriguing results, glimpses of structure, correlations of pattern, but there are also semiotic ingenuities, projections of our own desire for certainty, our own anxiety before the irreducible fallibility of human language. The current wave of experiments applying artificial intelligence to the possible decoding of animal communication would gain enormously by absorbing semiotics, and in particular biosemiotics and zoosemiotics, not only as an epistemological framework, but also as an ethical and philosophical one. For semiotics reminds us of something crucial: translating an animal science system into human language is not the same as translating between two languages, not even as translating intersemiotically between verbal and visual codes. It means translating across different regimes of interaction, functionality, and interpretability. In many of the projects that Nicola and Daria are systematically examining, the prevailing image is that of artificial intelligence being applied to the decoding of animal communication, or more broadly, of non-human and more than human science systems. This is how the work is usually presented, and it is indeed fascinating. Yet from the vantage point of cultural semiotics, and here it is crucial not to split cultural semiotics from biosemiotics, since the Tartu tradition cultivated their deep interweaving, the philosophical provocation may be a different one. Perhaps these projects are not really about animal intelligence, nor about animal language. Perhaps they are about artificial intelligence and about the language of artificial intelligence. We employ AI to decode the signals of whales, of birds, of cephalopods, but what is gradually revealed behind this enterprise is our growing preoccupation with the other side of the translation, not what the whales say, but what the machine says. We imagine we are translating across species, but in fact, we are learning to translate across regimes of artificial semiosis. In the end, the dream of interspecies translation may be less about entering the minds of other animals than about confronting the alien intelligence we ourselves have built. We thought we wanted to hear the voices of whales. What we may really be trying to understand is the voice of AI. Thank you.
Thank you. Okay. Thank you, Massimo, for your introduction. I'm Nicola Zangiaro. I'm a biosemiotician from the University of Turin. And actually, I'm very glad to this project because it's really fascinating how nowadays there are a lot of many projects that try to understand animal communication through AI. If you are not aware of this project, we are talking about Chatty, for example, Chat, Dolphin Gemma by Google, for example, ISPA. Okay, so I would like to present just a little corpus of analysis, just 2 projects, and I will focus on one of these at the end. But actually, I want to explain how this promises on the relationship between AI and animal communication are really fragile. And I will expose to you some critique of fundamental insight of this project. And after that, I want to focus on the task of biosemiotician nowadays in front of this challenge, and the role of zoosemiotics between AI and animal communication. So we can start with these little corpus of analysis. Chatty and ASP are not like little project, but for example, Chatty start in 2020 with $40 million grant, and after 2 years duplicated. For example, Azaraskin, that is one of the co-founder of ASP, said in an interview that machine learning can turn semantic relationship into geometric relationship, and that a language can be represented as a shape defined by the relationship between its concepts. So I want to show you that all these projects, okay, share one common background, that language have some universal structure. And this is why they believe that through AI, we can reconstruct a map between semantic concepts. As you can see in the slide, for example, for this project, all human languages have an intrinsic universal structure that connect words and meanings. And they reproduce this analogy with animal communication, understanding that all species like sharing a universal structure of communication. I don't criticize this model. I just want to show you the premises of this project, that all these project sharing. And one interesting thing is that, for example, Google declared that with the Dolphin Gem that in 2026 we will talk with dolphins. So we will create a dictionary human dolphins. So in this regard, the rise of AI translation project, as Massimo introduced us, have some kind of problems, but we can focus on the shared methodology of this corpus of project that they're like developing right now. For example, we have collect large-scale bioacoustic and behavioral data. We have a shared methodology that segments and classify acoustic signaling. For example, in a very big data collection from the 80s, for example, we can recollect in a very big archive the signaling from the whales that are recording in the 80s and nowadays are in the internet universe. So they correlate signals with observed behaviors in social context, obviously, and train neuronal networks to identify regularities and latent structure. But there are many common assumptions that is really like problematic from a semiotic perspective. For example, animal communication is structured like human language. As we well known from Seebeok and Danesi show us, we have like models that is a continuity modeling, but we have some kind of very big difference between animal communication and human languages. For example, iconicity and index and symbolicity like levels. And meaning is discoverable via algorithmic decoding. So sometimes this project talk about translation, sometimes decoding. We are not able to distinguish if translation is decoding animal communication and vice versa. So, and one of the assumption is universal translation is possible through patterning recognition. So, like citing a very knowing work by Soren Brier, is a massive amount of data enough? So, for example, Chetty, as you can see in the slide, for example, this is a very big collect of data. Now we have ChatGPT 3, we have ChatGPT 4, 2, sorry. So Chetty is inside of this like big amount of data collection, very big. So, but Chetty use AI to translate sperm whales, for example, click using languages model. And this is really anthropocentric methodology to apply. And this assume there is a code to decode inside the living beings, like translating a foreign language. So Daria will spoken about this understanding of how to decode like the tree of life from this project perspective. But whales, for example, clicks are part of social, affective, and ecological life understanding. So how AI can like decode these embodied, meaningful expressions. So the problem is the Ceti project, for example, risks to flattening the complexity of animal communication. This is obviously no. So for my biosemiotic understanding, meaning in nature is not decoded, it's lived, felt, and co-created. And this is the reason why I want to like show you for my, this is my like understanding of the task of biosemiotician nowadays in this respect. For example, we can apply a very strict semiotic analysis, no? Semiotic of text that is really powerful in Italy right now, no? For example, I analyze this scientific paper where you can see this image where they show the multimodal construction of how they decoding whale signaling, no? But if we like apply this strictly semiotic methodology, we can see that, for example, reveal very fragile structure in how they expose the result of this project. But this is not enough for me, because the powerful of biosemiotic analysis can show us, for example, in this second paper, where a group of mathematicians show in 2010 how the climate change are changing the channeling where the whales are communicate each other. So where the communication of whales are changing in relation to the acidification of the ocean, no? So, for example, the task of biosemioticien and ecosemioticien too is, for example, to analyze how in front of climate change, the whales can change how they perceive the environment and how they communicate each other. So this is just a few examples, because I want to introduce that this is my personal point of view about biosemiotic standpoint. So, for example, for my perspective, there are a lot of limits of semiotic analysis in semiotic of the text analysis, because, for example, language in living beings are not a fixed text, not a static text to be deciphered like the Rosetta Stone or dead languages, but rather a dynamic semiotic system in constant evolution. So there are a lot of limitation of textual semiotics when applied to analyzing living, adaptive, and evolving communication system. This is the reason why here we can see like the powerful of those semiotic analyses in the collective volume by Maran et al. So, for example, we always forget that we are animals, so we share some kind of spaces of overlapping Umwelten, no? So this is the reason why humans obviously are capable of making sense of all the animals, but not through the mediation of AI, through like shared spaces mediated through like shared environment and joint activities and so on. So, for example, when I show this presentation in the University of Cagliari, rightly Ludmila said to me, "But Nicola, this is a problem that we have in every translation between our language too, for example, no? So how, for example, this project can fit inside our semiotic translation tradition? No, for example, yesterday, Susan was talking about the difficulties and the powerful of translation, no? So, for example, in Jacobson typology of translation, where you can see these three understanding of the translation, we have the intersemiotic translation. That is, from Jacobson's point of view, from verbal sign to non-verbal system. For example, a novel, no, that translate in a painting, no. So this is a very epistemological issue because, for example, this project, for example, Chetty in this focus, inverts Jacobson model. So, for example, instead of trying to translate the verbal to non-verbal, it projects human linguistic categories onto non-human signals. So from non-verbal to verbal. And this is not at all a black box where something happened. It's just a code construct by human beings and by our anthropocentric and linguistic categories. And this is not intersemiotic translation, but a retro projection of human language structure. So here, some critical point of this project from my research right now. For example, the first critical point is even human-to-human translation is obviously never fully isomorphic. This project says that in the future, we will translate perfectly the animal communication. So this is a very ideological perspective to understand the complexity of living beings. And another critical point is in this cross-species context, meaning is even more embodied, situated, relational. And if we try to understand living beings through a mediated AI without any Umwelt understanding of the world, how we can trace this powerful embodied communication that every living beings have, no? So Chetty risks to reducing whales' semiosis to a static code legible to machine, erasing its pragmatic and ecological dimension. So to conclude, I want to show you some very core biosemiotic concept that obviously you already know, to re-understand the relationship between AI and animal communication through our field, biosemiotics. So for example, we can use Umwelt theory, obviously, is the ground of our methodology from Jacob Boyne's school. Everyone knows this theory, but the important things is that, for example, we can highlight how AI system lacking embodiment and cannot inhabit an Umwelt. And this is really problematic. And we can help this kind of project to re-understand their position, no, through animal communication, in front of animal communication. Semiotic freedom, a very, very deep concept of Jesper Hoffmeier. It really helpful here to understand that animal communication is not like an open window to us, but there is some kind of opacity where we cannot decode everything in animal communication. And this is why meaning is, as Umberto Eco said, an opera aperta, no? An open work. Every time is open and free. And this is the reason why this concept, it marked the evolutionary divergence of species semiotic capabilities and resist computational formalization. And this is really interesting because semiotic freedom resists to the development on AI to translate living beings. And the last concept by Kalevikul and Peter Torup, very fascinating concept that I want to develop more in these years, is biotranslation, published in a book edited by Susan Petrilli, is in very general term here, the process by which signs are transmitted between different Umwelten or semiotic system. Unlike linguistic translation or EU translation, biotranslation operates within ecological and affective constraints too. So we can understand each other through unconscious biotranslation every time we see each other, every time we live together in the same environment. And this is really important because it requires interpretive compatibility and not syntactic correspondence. So this is my last slide, because I want to show you that somehow we live in a very performative environment nowadays. We try to collect a lot of data and translate, but maybe we can slow down and see how, for example, Jane Goodall lived inside of the forest with gorillas and chimpanzees to understand each other, for example. So AI is a kind of historical shift from field-based observation, no? This ecological ethology, fantastic design and developed by Jane Goodall, to data-driven, impersonal collection, totally. And signification, for example, in this case, from a biosemiotic perspective, emerge from within an Umwelt. So no disembodied decoding is possible nowadays. So AI obviously lack Umwelt, as I said before, intentionality, affective grounding, semiotic freedom, and so on. So, but translation and biotranslation is really important because it's not possible without word inhabitation, and this mediation become a simulation. So we are every time talk with us another time through AI mediation. So for conclude, for the comparative perspective of Zoosemiotics, by contrast, the embodiment of the meaning, the biosemiosis, has central importance. Thank you for your listening.
Sorry, we need technical help to find the rest of presentation. I can give you.
Do you have a PowerPoint as well?
Yes.
Or just a Google? Because the PowerPoint's easier.
As well. I always have feeling like we are rock stars in biosemiotic gatherings. So this microphone basically highlights this 2000 vibe of. So I will conclude our presentation in discussion about artificial intelligence, and probably it's a bit controversial because we are in biosemiotic gatherings here, and I will focus on artificial intelligence instead. What I want to discuss with you today is mainly computational models, which are largely used in animal communication studies, and to see how beneficial that can be, or what kind of challenges they can bring. So first, we will briefly introduce how we work with AI in our project. Then we will discuss the main computational models used to deal with animal communication based on the experience of other projects and the methodologies and results they bring to the table. And finally, we will see how biosemiotic and zoosemiotic approaches can change the way computational models developed. And surely we cannot face this discussion without addressing the question of agency. So when we're talking about development of AI tools for translation of animal communication, there can be presumed different ways to how to identify the problem and therefore how to solve it. And curious part about how algorithms work is very much in relation to these two questions. The specific aspect of currently used AI tools that they are prompt to provide an outcome, so you will have answer in any case. But the validity of this answer, this is the main concern for us as the researchers. So let's briefly reassess types of AI which we have today. And AI is incredibly good in three main processes for what they're used. So data labeling and categorization, first semi-supervised or supervised, and then algorithm can do it automatically. Then pattern recognition and statistical prediction. So here we are coming with mathematical or logical models, and text generation, famous ChatGPT or other generative AI we all may know very well. So how these models are used for animal communication translation or attempts of that. So first we have narrow AI, and sometimes it's known also weak AI. Don't confuse it with this weak code name, because it is actually a very powerful tool which is focused on performance of very narrow particular task. Sorry. Yes. I was thinking, where is this noise coming from? So in this case, for example, image or bioacoustic data recognition and collection, which is very interesting because previously we had researchers like Jane Goodall sent to Africa. Now we can have autonomous robots, for example, which can detect and collect data for us. And it is very important when we are moving for the next stage of general AI. So general AI is less supervised models, which are more broader, which largely used for work with natural language processing, as for example, automatic translation or text generation, again, famous ChatGPT, DeepSeek or other type of models, very much used for the natural language because they were created to translate and work with natural language, but not exactly to collect and translate bioacoustic data. We have trend prediction, which is actually somehow very useful when we're talking about sonograms, for example, which you did see in Nicola's presentation. For example, the collected data from whales is analyzed through this method called sonograms, which is a graphic visualization of bioacoustic data, which somehow allow better and faster analysis of whale communication as we can grasp it through our devices or our umwelt. And obviously it's used for process automation, for example, tracing activities. As for example, we cannot just stand behind the whale and collect the data. We need different tools to do that. But in all this, it is important to know that AI, first of all, is a tool created to augment human user capabilities and based on human needs and our ways of communication. So let's look at the approaches of AI machine learning that are used today in the project about which Nicola was talking previously. So primary AI machine learning approaches include large language models, exactly as Nicola told in CHETI or Earth Species project, which are building, as they call it, first ever large language models designed to analyze data from species across the tree of life. This to adapt text processing techniques to decode animal communication patterns. So basically, they exactly take the same type of model of processing of natural language, recognizing patterns and sort of translating through categorization. Then we have deep neural networks for bioacoustics. So again, we are working with the sound. So this is based on convolutional neural networks that convert bioacoustic data to spectrograms for analysis and deep learning models specifically designed for computational bioacoustics. Then we have transformer models. So transformer architecture for bioacoustic sound event detection, moving beyond traditional convolutional neural models to capture long-range dependencies and also create sonogram transformers which work directly with audio sonograms. So it is just a bit deeper level to work with the sound directly, sort of translated and made understandable for machine. Then we have unsupervised learning and dimensionality reduction, which basically works on the latent spaces identified within the patterns in order to avoid human bias. Because as I said before, AI as a tool very much concentrated on our Umwelt, but it's not necessarily means that it's anyhow respects the Umwelt of other non-human animals. And then we have specialized architectures which are created for few short learning models for species with limited training data. For example, we have a lot of data collected about whales, but we cannot say the same about all the creature to who there is attempt to translate their communication. So key technical pipelines are audio processing, labeling and pattern extraction, pattern analysis, and for translation or mapping. So we see very classic and though very narrow approaches in AI to such a complex tool as animal communication. Also, within these approaches, it's very important the way data is collected, and it largely reflects the limits of human Umwelt as challenge to grasp the complexity of animal communication. Moving forward, we proposed in our part of our research a new approach which relates to the creative part of generative AI that can be used for animal communication translatability. And we were looking for the potential of current generative AI tools to have access to the complexity lying between holistic experience and translatability and natural language. Starting from an assumption of the limits of natural language as primary modeling system, we were scaling up from Lotman's to Sebeok and Danesi understanding of the modeling systems and presumed that generative tools can help to overcome this gap. Paraphrasing well-known expression, we cannot know through the limits of primary modeling system how is to be a bat. But we can move from these limitations through imagining how it is to be a bat through secondary and tertiary modeling system. So this is more broad understanding, which obviously focused on us as the researchers and not exactly on the object of the research. But I started my presentation stressing that with AI, it is important to ask right question. The right question in non-human animal communication translation would be, what do we actually looking for to translate? Do we translate patterns? Do we translate how non-human animals make sense of the world? Or do we want to find that besides our differences, we all use the same categories to identify objects and processes? To answer this question, it is crucial to understand how similar or different our process of interaction with the world as individual creatures. AI is based on human Umwelt and works on specific narrow parts of categorization and analysis, and often closely attached to our use of natural language. Obviously, without use of natural language, we would not be able to create AI tools. However, it is specifically limited and do not allow us to grasp the complexity. So the problem here is the model and approaches which we have to the translation. And particularly, I like the approach of described by Adonetti. It's a difference between informative and manipulative models. As a humans, we say a lot of words, but how much impact this communication have in comparison to the animal communication, when every action is directed as impactful action. So should we maybe go from the other direction and look not at the individual Umwelt, but as a system? The translation of whale communication in this case starts from collection of the data, from the tools like autonomous robot with AI-based software that allow to detect and collect bioacoustic information, frequently detecting acoustic activity and especially changes. And with deep learning tools, we can, for example, extract final scale details from cetacean spectrograms. but also AI has to have long-term memory for processing and performing classification, which at this point is quite difficult. AI at this its state of art doesn't really have long-term memory as we humans have, for example. Obviously, applying convolutional neural networks can indeed help with sort of phonetic analysis of bioacoustic data produced by whales, like coda type classification, vocal clan classification, individual whale identification. But most of all, it helps with understanding it as a system. So, for example, the changes within their communication. And that can allow us to go broader than individual events of data samples to the system and highlight regularities and predictable and non-predictable changes. So to briefly conclude, we indeed, in application of AI tools to non-human animal communication, should see a shift from the analysis of communication alone to broader investigation of semiosis, such as relational and context-dependent processes through which signs acquire meaning with ecological and social system. Possible use of AI tools based on secondary modeling system to descriptive analysis of the complex non-human sign systems, embodied cognition and communication. But especially, we need new computational models outside of natural language communication or processing boxes that are targeted specifically for human umwelt. And how can we resolve this? Luckily, it's not anymore, or soon not anymore, the problem of researchers trying to explain to a specialist in AI how to code some tool which would allow us to process this. Indeed, today with the wipe coding and prompt coding, we can try to implement our models which are based on our findings alone, and then obviously improve them with the help of professionals in this area. So we thank you for your attention, and unfortunately Massimo not yet here, but we have 3 minutes for discussion.
Okay, so we have 10 minutes for questions. Well, what is the semiotic difference between animal signals and language? Because when you present that you use natural language processing to analyze this animal communication, if there is semiotic difference between animal signal and communication and human linguistics, since there must be some differentiation of this language processing AI.
Yes, of course. They are just 2 different things. What we were talking about is that the projects which, for example, work with bioacoustics and sperm whale communication, they look to find the touching point between natural language and sounds produced by whales as their vocal expressions, as well as the sound produced with their bodies, like coda clicks, for example. And they are looking to analyze it within the phonetic, here it is. Okay, yes. So in this paper, they explain how they separate this type of sounds and how they analyze it within the predictive patterns. It is based on their methodology, because their methodology and aim is to show that whales can categorize their objects and events of environment alike we humans do. But within the perspective following Sebiok, for example, we cannot agree with them 100%. But this is what AI can do. So our task is to understand how we can change the AI models to be more holistic, to grasp more holistic experience, which is not even available to our Umwelt based on our limits.
I always uncomfortable with the notion of autonomous robots, for example, using the term autonomy in the context of which is actually, okay, it's a metaphorically used, or it's a sort of misnomer, because real autonomy requires singular freedom.
Mm-hmm. Yes. Mm-hmm. Yes.
When we talk about autonomous robots,
I definitely agree with you. Obviously, they're not autonomous in semiotic terms. It's just a common term to call them within the scientists. But obviously, as you can see in this model, they are supervised or even semi-supervised. So a person attached with a drone, the robot on the whale, and then robots stay with the whale. So it's not somehow controlled anymore by researchers. So it has this part of automation. But obviously, we always should presume the part of the designer and the part of the researcher who is connected there, collecting data. And on one hand, having something which can go on its own is very useful, because we won't be able otherwise to follow whales in this way. Do you mean neutral, or what kind of honest?
So, what is the status academic of AI? You know, all the academics say students, you can't use AI. So, there is such a thing as systemic convergence in levels of savings. You can have a soft answer, search, and you can have deep search. In the soft search, you will probably have Fox News, Yahoo News, and rubbish. It comes out as factual. If you have a deep search, it starts to go to another level. And the reason why it does that is economic. It's cheaper to give your customer what they really want, which is the soft answer.
Thank you so much. I really appreciate your question, because it's actually were two questions. Can AI be neutral? And what we have in the basically recommendation system search, which was the topic of my PhD dissertation. So answering the first question, no, AI is never neutral. It's a misleading misconception. First of all, AI was designed by a human, which had certain visions and opinions. Second, AI was trained on data, which was selected by some human. And also, there were, like, if you, like, I believe we all have sort of experience using large language models and sort of, GPTs, like ChatGPT or DeepSeek. For example, ChatGPT had older version ChatGPT 4.0, which they removed for some point, but they had to put it back. Why? Because ChatGPT is programmed to be the most opinionated large language models existing today. If you use, for example, Claude Sonnet of Anthropic, which is more soft and more humanistic oriented, or even DeepSeek, they are more neutral. When you ask ChatGPT, ChatGPT always answer, "That's a great idea, marvelous story," which is definitely very opinionated. And somehow people really like it, because it's connect on the like emotional level, and not logical. But answering second part of the